Okay, functions of the endocrine system. Sexual differentiation, growth and development, continuous maintenance of the body's internal environment, corrective and adaptive responses during emergencies. In addition, there are several principal endocrine glands: the hypothalamus, the pituitary, the thyroid, parathyroid, adrenals, pancreas, ovaries, and testes. Overall, the endocrine system is there to regulate organ function. Hormone levels are maintained at constant levels, hopefully, if our endocrine system is working appropriately. Most hormones are directly released into the bloodstream. I'm going to start off by talking to you about some of the different glands and the hormones that are created in each gland. If you don't understand what I'm saying right away and it's making nonsense, it will make more sense as we progress through this and talk about each of them in a little bit more detail. But in order for you to truly understand the nursing process and all of the disease processes, you do have to have a handle on the different glands and what glands secrete what hormones. Okay, the hypothalamus basically releases either your releasing hormones or your inhibiting hormones and sends messages to your anterior pituitary gland, sends messages to your pituitary gland so that they can release further hormones. So the hypothalamus makes these releasing hormones. Those releasing hormones are your corticotropin releasing hormone, which goes alongside with your adrenals, your thyrotropin releasing hormone, which goes along with your thyroid, your growth hormone, which goes along with your anterior pituitary, and your gonadotropin releasing hormones, which deals with your reproductive organs. So it all starts with your hypothalamus. Your hypothalamus makes these releasing hormones, sends a message to your pituitary gland. We're going to talk in great detail about the pituitary gland, but you've got your anterior and your anterior and posterior pituitary glands. With your anterior pituitary gland, you have your growth hormone, which increases the growth of bone and muscle, promotes protein synthesis and fat metabolism. You have your thyroid stimulating hormone, which stimulates synthesis and secretion of the thyroid hormones, T3 and T4. You have your luteinizing hormone, which produces estrogen and progesterone and testosterone for males. And then you also have your ACTH, which is your adrenocorticotropic hormone, and that deals with your adrenals. In your posterior pituitary, ADH, it's an antidiuretic hormone, or vasopressin, as it's also known as, and oxytocin are released. The ADH, or vasopressin, controls the excretion of water by the kidneys, and oxytocin is related to increased contraction of the pregnant uterus and milk ejection for breastfeeding mothers. The adrenal cortex secretes aldosterone and glucocorticoids. Glucocorticoids affect metabolism of all nutrients, regulate blood sugar, regulate growth, decrease the effect of stress on the body. Aldosterone deals with sodium and potassium, increased sodium absorption, and increased potassium loss by the kidneys. And the adrenals, as far as your adrenal medulla, you have your epinephrine and your norepinephrine, which are neurotransmitters for your sympathetic nervous system. Your thyroid releases your T3 and your T4, which increase metabolic rate, increase protein and bone turnover, necessary for fetal and infant growth. Your parathyroid glands secrete PTH, or your parathyroid hormone. This regulates serum calcium levels. And then your pancreas you are looking at your insulin, which decreases blood sugar by facilitating glucose transport across the membranes of the muscle, liver, and adipose tissue. Also, the pancreas secretes glucagon, which increases the blood glucose concentration, and somatostatin, which delays intestinal absorption of the glucose. As far as the ovaries release estrogen, which is necessary for the development of all female sex organs, and progesterone, which influences the menstrual cycle and stimulates growth of the uterine wall and maintains pregnancy. The testes release the androgens, or testosterone, which is necessary for the development of male sex organs, secondary sex characteristics, and also aids in sperm production. Alright, negative feedback loops. Negative feedback loop is for the regulation of hormones. If you have a rising hormone level, it negates the initiating change that triggered the release of the hormone. So what does that really mean? The feedback loop describes endocrine regulation, so regulation of hormone secretion by hormones themselves. Endocrine glands respond by increasing or decreasing the amount of the hormones secreted. Hormone secretion is determined by the hormonal levels in the circulatory system. Endocrine glands release hormones directly into the circulatory system. Most hormones travel to the target tissue to increase or decrease activity. An increase in the secretion of the hormone occurs when low levels of the hormone are in circulation, which causes a negative feedback loop. So, if you have low calcium, your parathyroid gland is stimulated to increase your PTH, or your parathyroid hormone. Calcium mobilization is increased from bone and increased calcium absorption in the gut. Then your serum calcium is increased. That increase in serum calcium stimulates the parathyroid gland to shut off release of the parathyroid hormone. So, I know that sounds like a lot, but basically, so if your hormone concentration is up, the production of the hormone is down. If the hormone concentration is low, the production of that hormone is up. Okay, target cells. Target cells have hormone receptors on and in the cell. We'll talk about upregulation and downregulation in just a minute. First messenger is the hormone. Second messenger is inside the cell. Even though hormones are distributed throughout the body, only those cells with appropriate receptors for that hormone are affected. The more receptors, the more sensitive the cell is to the hormone. Target cells have hormone receptors on the cell. The plasma membrane has receptor sites that are for water-soluble hormones, because water-soluble hormones cannot make it through the lipid bilayer of the cell membrane. Intracellular is for fat-soluble hormones that can easily diffuse through the membrane. Target cells recognize and bind specifically to their particular hormone and initiate a signal to appropriate intracellular effectors. Sensitivity to the hormone is related to the total number of receptors per cell. Upregulation means there is a low concentration of hormone, and so there is an increased number of receptors per cell. Downregulation is just the opposite. A high concentration of the hormone, therefore a decreased number of receptors on the cell. Okay, hormone disorders can either be primary, secondary, or tertiary. Primary means there's an abnormality in the actual endocrine gland. secondary abnormality in stimulation from the pituitary, or tertiary abnormality in stimulation from the hypothalamus. There can also be target cell failures, so receptor-associated disorders usually deal with water-soluble hormones. There's a decrease in the number of receptors, which leads to insensitivity to the hormone. There can be decreased or defective hormone receptor binding, impaired receptor function. There can also be presence of antibodies against specific receptors that suppress or exaggerate target cell response. This can reduce available binding sites. Intracellular disorders means that there is an inadequate synthesis of second messenger needed to transduce the hormone signal into intracellular events. Therefore, the cell fails to express the usual hormone effect. There's a failure to generate the second messenger by faulty response from the receptor binding site. The cell may respond abnormally to the second messenger. Remember that the first messenger is the hormone. It carries the message to the cell and interacts with the hormone receptor. The second messenger then responds to that. Alright, a little bit more about the hypothalamus and what it does. The hypothalamus makes releasing hormones. The releasing hormones are sent to the pituitary via the hypophyseal portal system. Those hormones are the corticotropin releasing hormone, the thyrotropin releasing hormone, the growth hormone, and the gonadotropin releasing hormone. The gonadotropin releasing hormone is related to the reproductive organs. The growth hormone, we talked about that earlier. The thyrotropin releasing hormone is related to the thyroid, and the corticotropin hormone is related to your adrenals. So remember, the hypothalamus is sending messages with these hormones to the pituitary, and the pituitary will release one of the associated hormones that we previously discussed. Just to clarify, the hypophyseal portal system is a system of blood vessels in the brain that connects the hypothalamus and the anterior pituitary, as you can see on the diagram there. Its purpose is to transport and promote exchange of hormones in order to allow fast communication between the two glands. Okay, so remember, the hypothalamus makes releasing hormones. Those releasing hormones are sent to the anterior pituitary gland. The anterior pituitary releases its stored trophic hormones into the circulation. Trophic hormones are hormones that have other endocrine glands as their target. They tell other endocrine organs in the body to grow and to secrete their hormones. The anterior pituitary hormones, remember, is TSH, which is your thyroid stimulating hormone, your FSH, which is your follicle stimulating hormone, your LH, which is your luteinizing hormone, prolactin, GH, which is your growth hormone, and ACTH, which is your adrenocorticotropic hormone. The main function of TSH, ACTH, FSH, and LH are to release hormones from other endocrine glands. Remember that your pituitary gland is located in the inferior aspect of your brain, and it is separated into two different areas, your anterior pituitary and your posterior pituitary. Please do not forget that your pituitary gland is ruled by your hypothalamus, okay? Your posterior pituitary gland secretes ADH and oxytocin. The other name for ADH is vasopressin. Hormones released by the, I don't want to confuse you, but let me make this statement before we go on with posterior pituitary. Hormones released by the anterior pituitary enter general circulation and are transported to other target organs. The two posterior pituitary hormones that I just mentioned are synthesized in the hypothalamus and then travel to the posterior pituitary for storage. Vasopressin, or ADH, as you remember from the very first slide, controls the excretion of water by the kidneys. Its secretion is stimulated by an increase in osmolality of the blood. So whether it's that's correct. Okay, vasopressin or ADH controls the excretion of water by the kidneys. Its secretion is stimulated by an increase in osmolality of the blood, or if your blood pressure is low, if you are hypotensive. Okay, releasing hormones from the hypothalamus tell the pituitary what to release in the blood. Trophic hormones from the pituitary tell specific peripheral glands to grow and to produce their hormones. So remember, it all starts with your hypothalamus. Your hypothalamus sends your releasing hormone to your pituitary, and then your pituitary gets even more specific and sends another hormone to the specific gland that that hormone is associated with. Okay, the thyroid hormone. A little review here of T3 and T4. T3 and T4 functions to maintain metabolism and regulate growth and development. Calcitonin acts on the kidneys and bones to decrease serum calcium levels. T3 and T4 are made up of amino acids, which either contain 3 or 4 iodine atoms each. T3 and T4, remember, are controlled. It's a controlled release by the thyroid stimulating hormone, which comes from the anterior pituitary. T4 maintains body metabolism in a steady state. T3 is 5 times more potent than T4 in regards to its increased metabolic action. Overall, T3 and T4 stimulate body growth, increase metabolic rate, heart rate, and glucose, regulates metabolic rate of all cells, regulates body heat production. The calcitonin, again, is there to lower serum calcium levels. So again, I'm going to try and repeat these as much as possible, but just remember where all of these hormones are coming from. So here we've got hypothalamus to anterior pituitary released thyroid stimulating hormone released T3 and T4. Okay, your adrenals. Your adrenal glands rest above the kidneys. You have 2 adrenal glands. You have the inner, which is your adrenal medulla, and then the outer, which is the cortex. You can see that picture there on the upper right hand of the slide. Your adrenals are necessary for the body to adapt to stress. Without the adrenals, severe stress would cause essentially peripheral circulatory failure, shock, etc. As you can see on the slide, the adrenal cortex stimulates glucocorticoids, which is your cortisol. It deals with metabolic effects, inflammatory and anti-inflammatory effects, growth-suppressing effects, levels of awareness and sleep pattern, and blood glucose concentration. Mineral corticoids, aldosterone, we'll talk about that in a little bit. Aldosterone directly affects ion transport by epithelial cells, which causes sodium retention and potassium and hydrogen loss. And then we have our estrogens and androgens, which can be converted by peripheral tissues to stronger androgens. Remember that as far as the glucocorticoids go, helps to regulate glucose metabolism, affects metabolism of all nutrients, regulates blood sugar, affects growth, has anti-inflammatory action. Cortisol, or glucocorticoids as I'm talking about, is the main secretory product of the adrenal cortex. Again, needed to maintain life and protect body from stress. And again, the secretion is regulated by the hypothalamus and the anterior pituitary gland. So, with this particular hormone, as we're talking about the adrenal cortex, you're thinking, started in the hypothalamus, went to the anterior pituitary. The anterior pituitary released ACTH, which is, remember, your adrenocorticotropic hormone. And the ACTH then triggered the release of the glucocorticoids. So hypothalamus, anterior pituitary, ACTH, and the glucocorticoids. Okay, mineral corticoids, the ACTH secretes these in response to the presence of angiotensin II, which, as you remember, is a vasoconstrictor. Aldosterone is increased by an increase in potassium. Aldosterone is the primary hormone for long-term regulation of sodium balance. Androgens, also controlled again by ACTH, when secreted in excess, it becomes a problem. Okay, the adrenal medulla secretes catecholamines, best known as epinephrine and norepinephrine, which, remember, are neurotransmitters. Remember, it's these that stimulate the fight or flight response and help to promote hyperglycemia. It can be stimulated by the sympathetic nervous system, hypoglycemia, hypoxia, hypercapnia, acidosis, hemorrhage, glucagon, nicotine, pilocarpine, histamine, angiotensin II. The adrenal medulla functions as part of the autonomic nervous system. When epinephrine is released, it decreases the blood flow to tissues that are not needed in an emergency situation. Also increases our metabolic rate, and, like I said, increases our blood sugar overall. Okay, the pancreas regulates carbohydrate, fat, and protein metabolism. Glucagon falls under alpha cells. Beta cells are insulin and are amylin. Delta cells, somatostatin and gastrin. F cells, pancreatic polypeptides. Insulin works with a negative feedback loop. Alpha cells create glucagon, which increases blood glucose. It's the antagonist to insulin. Beta cells secrete insulin, which promotes glucose uptake and synthesis of protein, carbohydrates, lipids, and nucleic acids. Amylin is co-secreted with insulin to regulate blood glucose by delaying nutrient uptake and suppressing glucagon secretion after meals. Delta cells secrete somatostatin, which regulate alpha and beta cell function, inhibiting the secretion of insulin, glucagon, and pancreatic polypeptides. Gastrin, the function has not yet been established. F cells secrete pancreatic polypeptides, which are released in response to hypoglycemia and protein-rich meats. Inhibits gallbladder contraction and exocrine pancreas secretion. So just remember that also the pancreatic islet cells, you've got insulin. It decreases blood sugar by facilitating glucose transport across cell membrane of the muscle, liver, and adipose tissue. Again, glucagon increases blood glucose concentration, and we talked about somatostatin already.